All right, so picking up where we left off yesterday, we had just brought this up, and I had asked you guys to copy this part into your notes. So the situation that we were looking at yesterday with making a certain number of goals was a binomial distribution. A binomial distribution has to meet 4 criteria. It has to be binary. There's only 2 possible outcomes. It's independent. Each trial has to be independent. The number of trials has to be fixed. So you have to know from the beginning exactly how many trials you're going to get. And then we have the same probability of success each time. So I want to look back at the beginning of this problem and see where we could record that all of those criteria were met. So back here at the beginning, it said about 70% of penalty kicks in a shootout are made. So right here, we have that each trial is either success or failure. Each trial is either a success or a failure. Success if it goes in, failure if it is a miss. All right, so that is the first criteria. The second criteria is that it's independent. Each kick is independent. Well, they told us that right here. Each trial is independent. Oh, ran out of room. Let's see if I can fit that in better. All right, each trial is independent. All right, so that was the first 2 criteria. What was the third criteria? Either unmute your mic or type it into the chat. What was the third criteria? First criteria was binomial, has to be success or failure. Second criteria is that each trial is independent, and we've identified where it said that. What was the third criteria for it to be binomial? What was the third criteria? Fixed trials. Yes, thank you guys. Fixed trials. So looking at the beginning of this problem, what is our fixed number of trials? Again, you can unmute your mic or type it into the chat. What was the fixed number of trials here? Yes, thank you, Casey. It says 5 penalty kicks. So the number of trials is fixed. N equals 5. We use N for the number of trials. Awesome, awesome, awesome. Okay, and then what was our last criteria? What was our last criteria? We had binary, independent, fixed number of trials. What else? The last component.
Was it the same probability?
Yes, equal probability of success or same probability of success each time. What is the probability of success in this scenario?
0.7.
Yes, 0.7, 70% right here. We had the same probability of success. We call that P, so P equals 0.70. Awesome, or 0.7, that's fine. 70%, 0.7, 0.70, any of those are fine. All right, we're going to go ahead and flip this over to page 12 now and check out the check your understanding. That's on the back side. So binomial random variables. X is my number of successes. Do you guys remember how we do the n with the mean and standard deviation inside of parentheses for normal distributions? For binomial distributions, we use a capital B, that means binomial, and then we have n and p, our fixed number of trials and our probability of success inside the parentheses. And we always have to check these 4 criteria. We can abbreviate this as BINS, B for binary, I for independent, N for fixed number of trials, and S for same probability of success. So we can just use the acronym BINS to remember this. To find the probability that our binomial random variable is equal to some number, we will always have a number here. We use this right here on the graphing calculator, but typically in a problem you will see it written like this. Means the exact same thing. The number on top is our number of trials, that is n. And then the number on bottom, which in this case is k. When we look at the graphing calculators, they use n, or they use r. This is how many successes we want. This is this number. Then we have the probability of success to the power of the number of successes that we want, and then the probability of failure to the power of the number of failures. Right, and again, this is how to enter it on a graphing calculator. How to enter it on a graphing calculator. All right, so let's look at the first question on the check your understanding. It says, for each of the following situations, determine whether or not the given random variable has a binomial distribution. So does it meet the 4 components? Does it meet BINS, binary, independent, fixed number of trials, and same probability of success each time? You play a game of whack-a-mole. From playing this game in the past, you know that you have an 80% probability of whacking the mole before it drops back into its hole. The moles pop up at random, and your ability to whack any particular mole is not affected by whether or not you whacked the previous mole. There are 20 moles to be whacked during one round of the game. Let X equal the number of moles you are able to whack. So I want you guys to tell me, does it meet the first criteria? Is it binary? Is it binary? Give me a yes or a no in the chat or by unmuting your mic. Is this binary? Yes. Okay, so if it's yes, what is success here? What would we define as success? Yes, absolutely, thank you. You whack the mole. So what is failure then? What would failure be? Yep, missing. All right, so we meet this first criteria. It is binary. Is each trial independent? Give me a yes or a no. You can give me a thumbs up also. Is it independent? Yes, we are independent. And I have highlighted how we know that it's independent. It says your ability to whack any particular mole is not affected by whether or not you whacked the previous mole. So we are independent here. Do we have a fixed number of trials? If so, tell me what n is equal to in the chat. Is there a fixed number of trials? And if so, give me the number in the chat. Yes. We have a fixed number of trials. We have 20 trials. It says there are 20 moles to be whacked during one round of the game. So we have a fixed number of trials. Do we have the same probability of success each time? And again, if we do, I want you to tell me what P is. What is our probability of success in the chat? Is there the same probability of success each time? And if so, tell me what P is equal to. Yes, absolutely fantastic. Same probability of success each time. 80%, that comes from right here, 80% probability. So is this a binomial random variable? Is this a binomial random variable? Yes. Binomial random variable because it met all 4 components. All right, let's read part B. Next, you play skee ball. You know that you have a 10% probability of getting any given ball in the 100-point hole. Let y equal the number of balls you must roll until you get 1 in the 100-point hole. I'm not going to ask the 4 questions separately. I want to know, so you need to go through the 4 questions. Is this a binomial random variable? Tell me in the chat yes or no, whether or not it's binomial. Is this a binomial random variable? Go through and check the 4 requirements. Ooh, I'm getting some no's in the chat. Okay, so if it's not binomial, which one or ones of those 4 components are being violated? Which thing did we not meet? Or if we didn't meet more than one, tell me all of them. What criteria did we not meet? Thank you, Georgia. Number of trials is not fixed. We said we're going to go until we get the first one. So we're not going to stop until we get that first one in. You have to know at the beginning exactly how many trials you get in order for it to be binomial. All right, let's go look at number 2 now, and then that'll wrap us up. Number 2, now you play a game called Tsunami Duck Pond, where there are 100 ducks that get pummeled by tidal waves. Among the 100 ducks, there are 20 with stars on the bottom, 30 with circles, and 50 with squares. You must reach your hand into the tsunami and randomly select a duck. If there's a star on the bottom of the duck, you win. After you select each duck, you must place the duck back into the tumultuous water. We're going to let W equal the number of times you win if you play this game, 10 times. W is a binomial random variable. They're telling us that there. We could go through and check our criteria, but we're being told it's a binomial, so we don't have to check the criteria right now. Identify the fixed number of trials, N, and the probability of success for each trial, P. So let's do N first in the chat. What is our fixed number of trials? Type that into the chat for me. Awesome. Yes. It says you're going to play this game 10 times. So N is 10. What is the probability of success? What is P? Type that into the chat. What is P? Yes. So I got 1 answer as a percent and 2 answers so far as proportions. Perfectly fine either way. P is 20 out of 100 or 0.20. I would accept either one, or 20%. You could absolutely write down 20%. And that's coming from up here. It says 20 have stars on the bottom out of 100 ducks. And if there's a star on the bottom of the duck, you win. All right, part B. Find the probability that you win exactly 3 times. So I want you to start off now by typing into the chat just what does my probability notation look like? Don't calculate anything yet. What does my probability notation look like? Type that into the chat for me. Think about what we need to start with if we're doing probability notation. And then what goes inside the parentheses. What would my probability notation look like? Not calculating anything yet. Just what does the notation look like? What letter does it need to start with? Let's start there. Not getting any answers yet. What letter does a probability notation need to start with? P. Yes. So I'm going to have P and then parentheses. W, yes. In this case, we want to know the probability that W is exactly equal to what? We want to know that the probability, or we want to know the probability that W, there we go, that W equals 3. So we're going to start off our probability notation just like this. The probability that W equals 3. Nope, that's okay, Georgia. You went a little bit further than what I was looking for, just the basic probability notation. But what you wrote is what we're going to move on to next. Now, do you remember yesterday when we were doing the shooting soccer goals thing, we had to figure out how many different ways we could get exactly 4 goals out of 5 penalty shots. And we wrote down all of those ways with check marks and X's. And then we talked about the formula way that we could do this using our graphing calculator. And the notation that we had for this was this double-decker parentheses here. What is the 10 up on top representing? What does the 10 on top represent? Yes, that's our number of trials. What does the 3 on the bottom represent?
Success?
Yes, that's our probability of success. So this right here tells me all the possible ways we could take 10 shots and get exactly 3 in. Then we do our probability of success to the number of successes that we want, to the power of the number of successes, so 0.20 to the power of 3. And then we have our probability of failure to the power of the number of failures that we would have. Well, if we get 10 trials and we want 3 successes, then we're going to have 7 failures. And the probability of failure would be 80%. Now, this notation right here, I can't put it into my graphing calculator looking like that. We have different notation when we put it into the graphing calculator. The number of trials goes here, and then we have this big letter C, and the number of successes goes right here. So I'm going to show you on the graphing calculator exactly how we put this part into the calculator. So I'm going to hop over to my graphing calculator app. All right. To get to the NCR, we push math, which is right below the alpha key. We come over to the one that says PROB, probability. So we arrow over to probability. And we want option number 3 that says NCR. N is my number of trials. R is my number of successes. So I'm going to choose option 3. My number of trials goes in this first blinking box. My number of successes goes in the second blinking box. Now, when you're using the app on your phone, you will probably have to type in the number of successes before you push the math button and go over to probability. You're probably going to have to type that first number in before you choose the function, and then you will tell it how many successes at the end. So I'm going to do 10C3 and hit enter, and it says we get 120. So coming back, I have 120 right here coming from my NCR. And then this part hasn't changed and this part hasn't changed. So I can go back to my graphing calculator and type in this entire multiplication problem here with my exponents. All right, so I'm going to type in 120 and then parentheses 0.20 to the power of 3. Then I'm going to use my arrow so that I stop typing exponents. And then parentheses 0.80 to the power of 7. And I hit enter. We get about 0.2013. So about 0.20. So the probability that W equals 3 is about 0.2013. All right. And that brings us within 2 minutes of the end of our class period. Do you guys have any questions for me before you leave? Do you have any questions before you leave? I do have office hours today from 11 to 11:30. So if you think of any questions between now and then, you are welcome to come back using the same link to come back and ask any questions you have during that half an hour of office hours. We are going to continue to talk about binomial random variables tomorrow in class. So you can also ask any questions that crop up then. If you have no questions, you are welcome to go ahead and leave the Teams meeting.